I think everyone is amazed at the revival of the AI, and especially since the release of Chat GPT and similar LLMs and AI products. People are always thinking about how AI can transform their particular work. There are concerns from every discipline regarding both the application of AI and also about the negative effects it might have on their profession. And structural engineering is no exception. As structural engineers, we are also interested to apply AI to create better structures, to improve our workflow, to improve the work that we do. At the same time, we are also concerned that over-application of AI might be harmful to the structural engineering profession, as well as the structures that we design regarding the safety, regarding the reliability, and so on. So there's a lot of interest in application of AI in structural engineering. This presentation that we are going to see was actually made at the conference organized by the Association of Structural Engineers of Philippines in Cebu in May 23rd, 24th. And I talked about what are the possibilities of AI helping our profession. And as I mentioned in this presentation, this is more of a personal reflection rather than a purely a matter of research. So I hope that we find this talk both interesting, but more importantly, something to think about. First of all, let me talk about three senses: the common sense, the driving sense, and the design sense. Common sense I will not mention because sometimes it's not that common, but let me talk about the driving sense. And I give this example often because when you're driving a car on a two-way road where the traffic is coming from the other side and you are going to overtake another vehicle in front of you, the amount of computations and the sensing and data needed to do that overtake is unbelievable, because you need to know the acceleration of your, ahead of you, the car coming, the distance, the speed, the power of your car, and so on and so forth. And then at some point you make a decision that I can overtake that. And some drivers can do that very well, and some keep waiting until all the cars have passed. So there is clearly a difference between one driver and the other, although they may be driving the same car with the same power, technologies in the car. So the driver's sense of driving is very critical in the way that they drive. So which is accumulated over time, which is learned, but also developed. It's a combination of learning and development, because everybody passes the driving test, but not everybody drives as well as the others can. The other part, the design sense, is to me very similar. I remember a long time ago when I started my company, at that time, of course, no computers, no nothing like that. So when we get a new project, the clients are waiting next day for the drawings. So there is no time to do all the hand calculation required to calculate the bending moment, moment distribution, and all. So, and then give the drawings to the draftsman to draw them. So what many of us in that time would do is that they take the drawing and they draw the reinforcement and put the numbers there already from their own thinking. And then after that, do the calculation and change a few numbers here and there that did not make sense. So that way, a design sense was developed, which could kind of replace the computation, because they didn't always need the calculation. And I remember when I did my first job, I had a senior who was there for 15 years before me, and I thought, this guy must be God in engineering. He must know something that I don't. But I saw him doing the same hand calculation with the frame redistribution that I was doing, and taking the same time to reach the same design. And I was thinking, this is not right, because he must be doing it much faster. He's getting paid 4 times more than me. He should be producing 4 times more job, but he's not. So which means there's a difference in design development, just like the driving skill development. So that is where I think our starting point of the discussion is. This is an interesting picture. I will come back to this at the end of my slide. You can see here a person is learning or using abacus. First time the computing, actually the counting got a technology to do that. And there are people watching him outside. This is a very typical situation. Some people are into it. Some people are just outside, just observing or being left out, or are not the adopters. Some are adopting, some are not. So this reflects many things in this picture, and I'll come back to this later. But future at this time is in technology, not only computing technology, every technology. We saw the shake table, advanced shake tables, analysis software, all of that. Any kind of technology, we are in that range, in that age that it is absolutely essential. Now, this is another very, something that is very close to my heart. This is an advertisement from 1981 for a computer which says, you can afford to satisfy the lust for power. They made a huge claim. This computer had a total memory of 1K. And I bought it, and I used it for my undergraduate thesis for writing a frame analysis program. And it has only 26 variables to do the programming. But they called it the ultimate power at that time. So we have had these claims of technology being the all-powerful all along. And some have panned out well, some haven't. But I think at this time, the AI is different. What we are seeing now is really different. This has not been seen before, what is happening in AI at this point. And I think everybody is worried and excited at the same time. Heads of the states are meeting, the countries are struggling. So everybody is either worried or benefiting from it. So this is a brief history. I don't have that much time to go through the AI development, but all I can tell you is that from 1950 until maybe 2014, it wasn't the mainstream until Chat GPT quietly brought this into the mainstream in such a way that almost now it is out of control. And those of us who have used it and are using it, you know what's happening to it. And anybody who's not into it is definitely the companies and everybody struggling with it. There's hardly any software that doesn't have an AI chatbot button in it now. So let's come back to engineering and compare two things, very important things, math and not math. Of course, engineering is based on math, but it's not math, because we do very sophisticated analysis only to round it off later by a percentage or a factor or a judgment and thinking, oh, this is not right. Let me add a couple of bars here. Let me change the section a little bit over there. So all the sophisticated analysis that we do with math doesn't actually become the final product. We still use engineering on top of that. And that's where AI and engineering are very similar. Because AI is not math. It's predictive. And it is very good at doing that, but not getting the exact numbers that you need. This is a very simple example. Two beams and with slightly different loads. So the reinforcement that you calculate from all the hand calculations or computer programs or whatever, the amount of reinforcement, let's say, theoretically, is 1255 millimeters square, but you end up providing, let's say, 3D25. The load is changed a little bit, you end up with slightly more reinforcement, but the end result is still the same, 3D25. So the computation, although precise and needed, doesn't affect the results because the result is a range ultimately rounded for practical reason. Cross-section sizes, members, material properties cannot be precisely dictated. Not every beam can have different reinforcement or different FC prime or different size. They all have to have a uniformity. So 87, 60, 70% are actually rounded or above all the computations that we have done, that the irrelevant computation we have done, because that doesn't actually get used. We can't use it for the practicality. So for that, which means we come to another problem. Another problem is, not another problem, but another interesting thing is that we are, as engineers, very good at doing computations when the problem is well defined. If you give a water tank of a particular size and thickness to any engineer with any software or even hand calculations, they will be very happy to give you the reinforcement on walls and slabs and all. Most of us can do that very well. But if you tell them that you just need a water tank or let's say 1200 cubic meter of water and shape is open, material is open, size is open, come up with the best solution, I think most of us will struggle even to start. Where to start? Circular shape, rectangular shape, concrete, steel, composite. What should we do? We will struggle a lot and we will almost certainly never arrive at the best solution because we don't know when to start and when to stop. That is where the AI has the most potential to help us to do this kind of thing, because it can train itself over data from various sources, come up with the reasonable answer, not the exact one, but the reasonable answer, and then we can go back and compute the reinforcement once we have the good starting point. But this good starting point is always a problem, because we always, like in ETABS or any software, if you want to do the analysis, you have to give the section sizes first, which is strange. That the point of the analysis is to give me the section size, but it is asking me before I even start. So if I start the wrong way, I get the wrong stiffness, I get the wrong response, I got the wrong reinforcement, but there is no real help in starting in the right direction to start with. So this whole design workflow, traditional design workflow, can be or needs to be augmented by AI somehow, because we can't keep on doing this refinement, because even we do that, can never be sure that we got the right answer unless we do optimization, which is a different field altogether, and it's very, very impractical. So the AI could help us jump these steps, because it doesn't care about the process. It cares only about the input and output, and nothing about in-between matters. So it can jump from architectural design to code-based design, or even performance-based design, depending upon how we train our models. So, which means that we have the final answer immediately, and then we can always come back and do the intermediate steps to verify that. Because many times, as all of us know, when you get a project, the first question the client says, how much is it going to cost us? Where can you save? And that is before we make the ETABS model and everything. So that answer can come from AI. Now, that's one side. This is the other side of story, which is even more alarming to me than what we have just talked about. This is most of us know what it is. But if I ask this to undergraduate or graduate students, many of them may not even know how to describe it. But I gave it to Chat GPT as an image and asked it to describe it for me. What is it? It's just a bunch of colors and pixels to Chat GPT, but it came up with a very, very complete, comprehensive analysis of what this diagram is, just by looking at the pixels. And more interestingly, it came up with the practical applications and a potential. It's a design analysis of columns in tall buildings where elements are subjected to significant axial loads, bridge piers, and so on. ChatGPT, it's not a structural design program. It's a general large language model, should know nothing about this, but it knows precisely what all of the structural engineering is just by looking at one image. It actually cannot look at the image. It just has pixels, colors, gradations. From that, it could interpret this one. So if it can do that, anyone can answer this, ask this question, doesn't have to be a structural engineer, and get this answer. So the understanding that we can get from the large language models in our work, our students, ourselves, is now, the potential is great. How many of us now look at a medical report and then go to ChatGPT or something, ask about what is this, and never consult the doctor? So we are cutting the doctor or the professionals out wherever we can get the answers. Same thing could happen to engineering. If you look at the ChatGPT now, these are some of the chatbots already there, although their engagement is low, but people are already putting up structural engineering specific chatbots there, trying to use the ChatGPT behind the scene, putting something on top of that and interpreting, and being the interpreter in between and getting this. The engagement is low, but people are already starting to do that. So which means there's an awareness, but this is all students, academic, enthusiasts, nothing serious here. Engagement is 500-600 conversation, 700. If you talk about other, there are millions. So this is really the beginning. But the potential of that is that as engineers, structural engineers, we can now understand the work of others around us in the overall project life cycle, because this is a project life cycle. Look at the number of steps there are. And as structural engineers, we are only handling one or two of them. All the other, we were just talking to about our colleagues here, that the money goes to other people in a project life cycle. The friend Ashraf, he always says that the real money is made by the property, consultants and dealers, because every time there's a sale, they get a percentage. No matter the cost is going up or down, market is down, they always get a percentage and keep getting it throughout the life of the structure. Structural engineers do the whole design, get to just once and a small fee. So we need to get involved in the larger part of the project life cycle, and AI has the potential to help us do that because it can give us the ability to understand the scope better and get involved in a broader part. That's why if you look at the AI application software coming out currently from the developers, they are in everything: planning and programming, schematic design, design development, construction documentation, bidding and negotiation, construction, post-construction. That's where the applications are going. Not much in design, which means the scope can be expanded through this for the work which is all based on our work, because structural engineering or structure has to be the basis for everybody to build upon. So we actually hold the core information, core data. We don't value it yet because, there's in the class, I always tell them that if you take a tall building and you take away the structure, the MEP will fall down, the architect's work will fall down, the interior will fall down, the cladding will fall down, everything will fall down. There's no structure there to hold it. So we actually hold the key to every other discipline, but we are still not making enough use of that power. So as we all know, AI works on data. Where is the data coming from? Where can it come from? These are the prime sources of data: public data, collaborative data, organizational, individual knowledge, and generated data. And rapidly, the companies are running out of the data in this stream, and the last real data ultimate will be generated data. And that's where the strength of AI for structural engineers lies, because we have the tools to actually generate data and reuse it in AI. And that, I think, is the one that why we as structural engineers can hold the power with us. And I will talk a little bit more about that, because public domain data is already consumed. And we can see the public domain data, Chat GPT already gave us a very good analysis of that moment interaction diagram. So coming back to that, how can we get the generated data? It's not that complicated, because we can create parametric structures. We can use the existing software that we have or the existing methodology that we have, and then we generate the models and then use those models to predict the results. So for example, for a beam design, typically we can generate a beam range from 5 meter to 20 meter with all section sizes, with all materials, and keep doing it, and maybe have it 5,000, 10,000 beams analyzed, valid design, acceptable design, economical design, give it back to AI. Next time, just give the span and the length, and it gives you the best result right away without analysis, without doing anything, because it has been trained on the acceptable data. It will not give you the section which won't work. It will give you a section which works because it has been tested through the training. So once we have the data, the prompts could be very simple. The first prompt is easy. What is the reinforcement for a given span and loading? Which is fine. We can also do it by other methods. But the second prompt is more interesting, because AI doesn't care about what is input, what is output. It doesn't understand beam span, beam length, and reinforcement. For AI, both of them are just data. Pure data has absolutely no meaning. So if you reverse the data training, you can ask the question, what are the possible range of spans and loads for a given section and reinforcement? So you have a precast beam, you can find where to use it. You have an existing building, you can say how much load you can carry. So you can reverse the data training to answer the opposite question. So the output becomes input, and the input becomes the output, and you can query the same model for things that you otherwise would be impossible to find. So that's another advantage of generated data and proper training. So this is a bridge, coming to slightly higher level models. Let's say this is a bridge, and it's parametrically defined. In fact, we are now currently working on this, almost ready, the new version of CSI Bridge. And you can run this model a few thousand times with different girder sizes, girder spacing, span length, capping beam size, and so on, and train and find the right span length and so on. So you can do that, and then if you complete the cycle from the analysis all the way to BOQ, to the cost, to the reinforcement, to detailing. So we can generate very valid designs and remove all the invalid designs and use those valid design to train back the software in such a way that you can now ask the questions that, okay, if I want to, so this is the sort of framework for that, one of the research that we are doing now. And you can ask the question, what is the most suitable length, girder size, and spacing for a bridge 300 meter long? Whether I should use short span and few girders or long span and many girders. Should I use deep girders and longer span, or shorter span and shorter girders? So which one is better? Because they interplay and each has a cost and performance implication. And it's not practical for an engineer to do all that for a particular project. We don't get paid enough. We were just talking about that also. So AI model, once trained, using our own software, our own knowledge on valid data, can give us the answers very quickly, and which is good not only for us, for the client, for the public, for the money, for everything, because you got the economical, reasonable design right away. So that's where the strength would lie. And then you can go back and then do the analysis and do the finite element modeling and all of that to get the real results. So people also often ask me, what's the difference between finite element analysis and AI? Actually, none. I shouldn't say none, very little, because both are metrics operations. The only difference is one is a deterministic, one is probabilistic. So one has exact relationship, one has estimated learned relationship, but both are basically relationships between input and output. So if you look at the typical frame analysis here or truss analysis here, the stiffness matrix would look something like this. Each element is given by AE over L and all of those formulas. So this is precise, this is known, this is good, and that works well. If you look at the same problem through AI, it will also do the same thing. It will have input and output, and using ANN, it will find the relationship or the factors correlating the displacements and the forces in the same way as the finite element strength. The only difference is they are accurate, exact, based on calculation. These are learned, and if you get more data, you learn more. Of course, you will probably get never enough data to get a matrix precisely the one that we use. But that's not the purpose of AI. Purpose of AI is to estimate a good starting point. The final design still needs to be carried out traditionally. So that brings us to customizing the AI for specific needs, because now we have the opportunity to train models specifically for each type of problem, each task, and each objective using generated data, because we also have the ability to generate data. For most of the AI models, the problem is where to get the data, because they cannot generate it. But structural engineering, because of our tools and our knowledge, we actually can generate the data by ourselves and then use it back in the AI models. So, for example, I often wonder that how many times a beam, 6 meter long beam, has been designed in the world? Maybe 1 billion times, because everybody does it. Your own company has done it so many times. Every time your own engineers sitting next to each other are doing the same 5 meter, 6 meter span beam, and they're each doing the same thing over and over. And how many different answers can there be for a 6 meter span beam? So if we accumulate that knowledge and we combine it and we share it and we train it, we can reduce this unnecessary work that we are doing. I remember a long time ago, there was a boom in textile industry in Pakistan, and everybody was doing textile factories. And this is before AutoCAD and before all of that. So there was one consultant who were very famous in only doing the textile factories. So they do is, because textile factory is the same. same loom, same length, same everything. So they would just take the drawings from one, erase the title, and then reprint it again and give it to another project. And this is a fact. This has actually happened. So one of the project, when they sent the drawings and they started the construction, they realized that the entrance is on the other road, not this side, because they forgot to flip the plan because it was reused. But my point is that we have now the ability to reuse our designs through proper training and through proper aggregation. Between the firm, between the organization, ASAP, for example, could take a lead in developing an ASAP AI where members can work together on that. So prediction, we were talking about how to predict things. Natural period, for example, of a building is something that we all want to know, and there are so many formulas here, 0.1 and that formula and this formula. But those formulas are either dependent on height or on number of floors, but not really the real configuration of the building with height, number of, the structural system, the no shear walls, with shear walls, so many other factors will affect it, but we tend to average them because they are based on average number. They don't have the parameters inside the equation that should be there. But if you use the AI for either simulated or actual observation for buildings with the parameters as well, then we can predict this better. And then we can use that as a reference for our own analysis. So we could use the specific building parameters to doing that. This is a research we did many years ago in which we used some of the project actually from Philippines and from our, to train an AI model to predict the natural frequencies. This is a certain building range, 30 to 40, 50 range, and certain configuration. And these are based on architectural parameters, and output could be the natural periods, column to floor area, wall to floor area ratios and reinforcement ratio and things like that. So you could, because we could use that data, we could use that output, you can train it, and then you could predict it. And it worked very well, even with limited number of buildings that we used for this model, because we trained specific models for each type of variable. And this was the comparison. We found many very good match between many of these, the numbers that we sort of predicted and then were actually present. So we could train the models to predict the numbers very quickly, reliably, not for the final design, for preliminary design, and for what is called the sanity check. That means not every one of us has the ability to see whether the results is reasonable or not, because we are not used to processing the number. The sense of the number isn't there. This is 34.785. We have 7 digits after the decimal, but do we really need that? And what is the significance of those numbers? So that we can easily get from the AI trained models. This is an interesting video. This is an interesting project coming from China, and actually quite interesting, because what they did was that they took the architectural plan and then they extracted through image processing the walls and the beams, and then they automatically used algorithms based on AI to estimate their size, then convert them into ETABS model, analyze it, design it, and finally get the final quantities. So you give a PDF drawing to the program, and it builds up a 30-story building ETABS model from it directly by using AI learning and image processing. And this is one example where it could do. On bridge side, we are trying to do the same thing. We are trying to see, so many old bridges do not have models. They have PDF drawings. Can we use those drawings to convert them directly into 3D models of the bridges, and then the departments can have those models for various purposes? So once again, AI can help with that. So, like I said, any one of us could do this, because we all have some software that we are using. We can use, for example, ETABS, I will say ETABS, to generate valid section sizes, then train those model on that, And next time when you use ETABS and you are entering, selecting a beam for a certain building and a certain location, it will say, no, 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 you should use this size, it will work. This size won't work because it has been trained on the previous data. Just like, prompting for our spelling mistakes. I forgot to spell anything. I rely on the spelling checkers all the time because it can anticipate next word and the spellings for that. So same thing, we could have models helping us to start with the good initial estimates of the sizes by prompting us while we are creating the models. And this is not far. It's already coming up in programs. Now, this is an interesting question. AI can't replace structural engineers yet. And I will tell you why. And who is being replaced? Well, let's see that. Currently, AI cannot do precise computations. It does not have the ability to do math correctly. Even small, simple beam design, it makes errors. Lucky for us, because the departments, our clients, want the calculation report. They don't want just to believe us. But it can help us to do that. And this is interesting. Chat GPT can pass the medical, law, and business professional exams with flying colors. So the three professions around us, Chat GPT can easily become a professional doctor, a professional lawyer, and a professional MBA, and because it passes all the professional exams. But it can't pass the structural engineering exam yet. Because of the computations involved there, it won't be able to do that. Okay? But it's not very far. So we have to do something before that happens. And the other reason is that accountability and quality assurance and innovative, sustainable solutions and creativity, we still have a lot of control on that. We still have that. And it is still something that AI will be doing very, very soon, and things will move out of our hands if we don't actively become engaged in this one. And the reason is this. Information. So far, AI models have been sort of model. Either it's a text model, or it's an image model, or it's a video model, it's a voice model, each one trained on one specific data, processing one thing at a time. But that has changed in the last couple of months. Multimodal models are now coming up. As you know, anyone who has used ChatGPT 4.0, Omega, or whatever, Omicron, they know that it can now process images and voice and text all at the same time, because they're being trained on information coming from so many diverse areas. And once that happens, then it will have the ability to connect the dots between various things like human being can do. And that's why people are so worried about AGI, the artificial general intelligence, and they're saying if that comes in, which some people predict is soon, some people say no. We used to talk about singularity, where human mind and AI will merge or cross each other. And at that time, people thought that's not going to happen. But we can see that very clearly, it's very near. So this is the reason that the power of AI is now going to increase dramatically. Last couple of points. We used to have this idea of the master apprentice in every trade. Generations after generation, the masters will train their sons or daughters or their apprentices, and they will train their apprentices, and that's how the knowledge and skills and the things pass through generations. And those people knew something about things that others didn't know. That's why they were called master builders and master craftsmen or master smith or whatever. But because they knew something, they have learned, combined with ability and intuition and inborn capabilities and all, but they became masters. So this is one of them. As most of us will know, Nervi. So he did amazing work 100 years ago, and he did them without computations of the current time. Imagine trying to create a finite element SAP model for that shell. We will spend months doing that, millions of degrees of freedoms, and we will be doing that. And he did it on a sketchbook through his hand computations, hardly any computations, imagination and understanding, and build all these huge structures. And there are many like masters like him. So if we get people like that, collaborate together with intuition, with knowledge, with understanding, with the power of AI, with the data, not just pure data, but data with understanding, data with all of that stuff, with wisdom and knowledge, everything put together, we have the ability to help other engineers so that the whole profession can elevate itself and we can charge more ultimately for our work and be the leader in this field, because we are using that very rapidly. See, people, we had the ability because we had primary data of the structure, but we didn't adopt it and it's gone. And AI is next that is slipping away. So coming back to that, the future belongs to those who embrace technology, and it is, I think, time for us to embrace AI because that is the technology of the time. Thank you so much.